Small factory makes bars of soap, and on any given day, the total cost, Y pounds, of making X bars of soap is modeled by a fixed cost, which I'm going to call F, and a cost that is proportional to the number of bars of soap that's made that day. Write down a general equation linking Y with X for this model. Y is going to equal this fixed cost, and then this second cost, let me call it C, is going to be proportional to X. So maybe I say that it's, well, I actually went with BX in the answers. They went with KX, and they also went with C for instead of the fixed cost, but I'm going to write it as Y equals F plus BX. So B is the cost for one extra bar. Just want to say it's not the cost of one bar because I've got a fixed cost as well. I'm just trying to make that clear. And that's our answer. As long as you can write down something in the form y equals mx plus c, and I would say you should really define your, parameters, then it'd be absolutely fine. The bars of soap are sold for £2 each, which actually means our revenue is going to be 2 times x. On a day when 800 bars of soap are made and sold, the factory makes a profit of £500. Let's deal with that first. So the revenue for that is going to be 1600, but I need to minus my costs. So the F plus BX. So I'll minus F, and then I'll minus, it'll be B times 800, so 800B. That will equal 500. I can rearrange this, give me F plus 800B is 1100. And then on a day when 300 bars of soap are made, so that's 600 made in revenue, but we're going to lose, it's going to be minus F and then minus 300B. A loss of £80 is made, so we're going to get minus 80. I'm using profit equals revenue minus costs, basically. Let's rearrange this one. F plus 300B will be 600 plus 80, 680. It is probably easiest to just put it in our calculator. By all means do it by hand, but just to be extra careful, it is there as a function. So simultaneous equations, two unknowns. I've got F as X, it's my first one. So 1, 800, that you could very quickly subtract them, but then you have to sub it back in. This is going to be quicker. So we get 428 for F and 0.84 for B. The only thing I'd say is because as I show that question, should I show my working? It's up to you. I think it'll be absolutely fine because we've had to create the equations and everything. We've shown our understanding. That the long way would be to, it's not actually that long, but minus the equations. So 500b will actually be 420, and from that we get b is 0.84. Sub back in. Okay, so maybe we should just show that extra bit of working. Sub back in. F is equal to 428. Therefore, y equals 0.84x plus 428. Just write that as our final conclusion for this part. With reference to the model, interpret the significance of 0.84. Remember, that was actually our value of b, which I did define earlier as the cost for one extra bar. Again, I don't want to say it costs 84 pence for one bar because there is that fixed cost as well. So it costs 0.84 pounds extra per bar. And then finally, we're asked to find the least number of bars so that we're going to make a profit. So we're going to solve, right. We know that we sell them for £2. So our revenue for X bars is going to be 2X. And I'm going to be minusing 428. I now know what my value of F is. And I'm going to be minusing that 0.84X. So revenue minus the costs. And I want a profit, so I want it to be greater than 0. That gives me 1.16x minus 428 is greater than 0, so 1.16x will be greater than 428. And I can solve this, just do 428 divided by 1.16 gives 368.96. So x has to be a whole number, just note that, it's the number of bars. So 368 wouldn't quite be enough. Even if it was 368.1, we would actually round it up to the next bar to guarantee a profit. Therefore, it's going to be 369 bars needed to make a profit.